Hello everyone, welcome to the next HCIE IoT course, Industrial IoT Gateway. Today we are going to learn about Industrial IoT gateways for fixed access using common IoT communication technologies. The industrial field has always been an important part in the IoT sector. In previous courses, I mentioned that the industrial field is closely related to production, and that is field has many things. For example, machine tools and robotic arms. In addition, the environments in the industrial field are harsher than in other IoT scenarios and require the use of a wide range of complex and demanding devices. As such, diverse interfaces need to be adapted in the IoT field. With the development of global industrial automation, it is crucial to have industrial IoT devices which meet the preceding requirements. Through this course, you will learn about the basic concepts and key technologies of industrial IoT gateways, as well as Huawei's industrial IoT gateways and their application scenarios. First, let's see how IoT is applied in industrial scenarios, what challenges IoT faces in the industrial field, and what kind of device an industrial IoT gateway is. Here, the industrial field is not limited to the production factory scenario, but also some sub-scenarios such as electric power and transportation. For example, smart meter, smart power distribution, and smart transportation also fall into the industrial field category. What challenges does IoT face in the industrial field? IoT faces 4 challenges in the industrial field. First, the industrial environment is very harsh, given that it includes scenarios with ultra-high and ultra-low temperatures. Therefore, IoT devices must be able to operate properly in an extensive temperate range, covering -40 degrees to 70 degrees. Furthermore, these devices are expected to be dust-proof, waterproof, and resistant to electromagnetic interference. Environments such as power plants have very strong electromagnetic interference, which affects normal communication between devices. This is something conventional enterprise-class routers cannot provide. Second, there are a wide range of devices in the industrial field. These devices have different interfaces and protocols. Therefore, a device which can adapt to all these protocols and interfaces is required. Third, cybersecurity is a top priority. Each enterprise has their own business threats to protect. Although most enterprises use private networks, they may still suffer from malicious attacks. Therefore, cyber and information security is a key consideration in the industrial field. Last but not least, IoT networks have complex O&M. There are a large number of terminals, and O&M complexity is proportional to the quantity of terminals. Maintenance is costly if professionals are hired each time an issue occurs. As such, a simple system is required. A simple and easy-to-use system means less complexity to O&M personnel and lower O&M expenses to enterprises. These 4 are the major challenges faced by IoT in the industrial field. An easy-to-use and powerful IoT gateway is crucial to address the preceding challenges. What functions does an industrial IoT gateway provide? As you can see from this figure, the IoT gateway is located between the terminal layer and the network layer, and serves as a bridge between the two. On the left, it is connected to the terminal devices. On the right, it is connected to the network, in addition to providing upstream transmission channels for terminal devices. The IoT gateway also offers edge computing capabilities, which will be described in detail shortly. Also, Industrial IoT gateway provides a protocol conversion function. There are many protocols in the industrial field, covering all sectors. Therefore, we need to convert these protocols on the IoT gateway and then transmit data out. Now, we have learned what an Industrial IoT gateway is. Let's take a look at its capabilities. But before we do that, we need to introduce the edge computing. So, what is edge computing? To put it simply, some of calculations that are originally performed on the central node are performed on the edge node. Originally, the platform layer processes and calculates all data, but now the IoT gateway can calculate some of the data that is not important and promptly provide the calculated data to terminal devices. This achieves a low latency, effectively protects the edge privacy of users, and reduce costs. This is because for the central node, not all the collected data is useful. So some unnecessary data can be processed by the edge node. In this way, the edge node shares some of the pressure of the central node. In the past, data is processed as shown in this figure. Data is generated on the devices and uploaded to the gateways. However, gateways do not have computing capabilities and can only function as a transmission device to upload the data to the cloud for processing. Now, as gateways themselves have computing capabilities, they can locally process some data with low requirements, instead of being processed by the central node. Of course, after the data is processed, the gateway still needs to notify the central node that the data has been processed. Edge computing is an open platform that integrates connection, computing, storage, control, and application functions. Compared to the architecture of IoT, the architecture of edge computing can be divided into 4 domains: the device domain, network domain, data domain, and application domain. Although edge computing is located between the sensing layer and the network layer, the edge computing architecture can be divided into 4 layers to provide the similar capabilities as the 4-layer architecture of IoT. What are the purposes of the hierarchical edge computing architecture? In fact, we divided the 2 layers between the device and gateways in the IoT architecture into 4 layers. In the hierarchical edge computing architecture, the device domain is equivalent to the sensing layer. The network domain refers to the network between devices and gateways. The data domain refers to gateways which process data in a way similar to an IoT platform. The application domain refers to diverse applications in edge computing. In addition to edge computing, the IoT gateway has another key capability, that is mesh networking, which is a type of network topology. This is another key concept in this course. Before learning about it, let's look at some typical network topology. A network topology refers to the layout of the network devices. First, let's look at the star topology. A typical example of such a topology is a wireless network we use at home. The central network device is equivalent to a router, and the other devices are all kinds of wireless terminals that we use. Although we do not have these cables in actual situations, you can use such cables to refer to wireless connections. The star topology features a simple structure and easy control. However, this topology has low reliability. For example, if the router is faulty, all devices cannot access the network. Next up is ring topology. Although the ring topology takes the form of a ring, information is transmitted along only one fixed direction. What problem could this cause? For example, if traffic is transmitted counterclockwise and a packet needs to be transmitted clockwise between two neighboring devices, the packet must pass through all the intermediate nodes. In this case, the transmission rate is low and the delay is high. In addition, if any intermediate node is faulty, the entire network will break down. Now, let's look at the third topology, bus topology. This topology has good scalability. When a new device needs to be added, we simply need to connect the device to the bus. However, if the network is interrupted, it is difficult to locate the problem because all devices are connected to the same bus. Additionally, the network rate is greatly reduced if many devices are connected to the bus. Lastly, and most importantly, mesh technology. What is mesh topology like? In the mesh topology, all devices are connected to other devices by cables. What are the advantages of this topology? When transmitting information to other device, each device selects the nearest path to connect to the other device. If a path is disconnected or a node is faulty, the node selects a second nearest path to connect to the device. Therefore, the mesh topology features strong survivability. Also, note that this topology does not require a control center. Both ZigBee and Z-Wave, which we have learned, use this topology. After learning about the concept and capabilities of industrial IoT gateways, let's take a look at the industrial IoT gateway products that Huawei provides. What you see here are the industrial IoT gateways that Huawei provides for different industrial scenarios. The capabilities and application scenarios of these gateways vary according to model. For example, the AR550 series is designed for harsh industrial environments. It has an extensive operating temperature range from -40 degrees to 70 degrees, which can meet network communication requirements needed for extreme temperature, humidity, or electromagnetic interference. The AR550 series is mainly used in power distribution networks, industrial control, and video surveillance scenarios. The AR532 and AR531 is used in scenarios such as power IoT and smart meter reading. Now that you have a brief idea about these products, let's see what problems they can solve for enterprises or scenarios. Let's begin with the charging pile scenario. Using an example where an enterprise uses ZigBee, industrial computers, and 4G routers for communication. A large number of devices are deployed, but the enterprise cannot achieve a good level of communication as they expected. ZigBee is a technology specifically for IoT and uses a mesh technology for self-connection and self-organization. However, when used this way, it is prone to interference. As a result, the enterprise achieves low operational efficiency, even though it has invested heavily in such a large number of devices. Huawei's industrial IoT gateways offer edge computing capabilities. after they are used to replace the preceding devices. The communication efficiency will be significantly improved. Also, leveraging Huawei's management platform, the enterprise slashes its operational expense while greatly improving its communication efficiency. Next, let's shift our attention to a street lamp scenario, where the mesh topology is used to effectively control smart street lamps. Although street lamp controllers use unique standards in the industrial field, Huawei's gateways can well adapt to these standards by using a Geographic Information System or GIS system to centrally manage street lamps. As a matter of fact, Huawei's Industrial IoT gateways are also ideal for the entire campus IoT. We all know there are many devices on a campus network. Huawei's Industrial IoT gateways can be used to centrally control all devices, including street lamps, parking sensors, manhole cover sensors, and many others. In short, Huawei's Industrial IoT gateways can be applied in both the industrial field and other fields such as smart campus to centrally manage devices and relieve pressure on O&M personnel. As we have mentioned in previous courses, the MB-IoT network of carriers can be used to control devices in the campus. However, some large enterprise campuses that have stringent security requirements do not want to connect their devices to carriers' public networks. In these cases, they can deploy a private network of their own and use Huawei's Industrial IoT gateways to protect their privacy. That's about all for Huawei's Industrial IoT gateways. Now, let's make a brief summary. In this course, we have learned about the differences between the gateway requirements in industrial scenarios and those in common enterprise scenarios. In addition, we have talked about the principles of edge computing and mesh networking topology, as well as Huawei's Industrial IoT gateway products and their application scenarios. In next course, I will introduce home IoT gateways. What role can those gateways play in our daily life? Let's leave the questions to the next course. Thank you for your watching. See you next time.